Today we're going to start to talk about bonding and nomenclature. Now we're going to do this in two parts. So we're going to look at ionic bonding and nomenclature first, and then we will look at covalent. So just a reminder about ionic bonding, that ionic bonding has to occur between metals and non-metals. And when this type of bonding occurs, the electrons between these two types of elements are transferred, okay? And then they result in a difference in attraction. So there's positives and negatives that get formed. We're going to show you in a second. And this strong attraction bonds these elements together into a compound, okay? And we form a new chemical compound that has a very specific formula and name. So I'm going to do 3 examples for you to show you how this happens. You should have seen this in junior science, so grades 9 and 10. And so again, this should just be a review for you. And if you have any questions or you need some extra help on it, just reach out. I am happy to help you. So if we take our first 2 elements, we have sodium and bromine. And the first thing that you need to know is, what types of elements are these? And if we go back to our periodic table right here, and we blow this up, we can find bromine is right over here, okay? And this is on the non-metal side of the periodic table. And there's sodium on the metal side. So we know that this is an ionic bond because we have a metal and a non-metal. Remember that sodium is sitting in group 1. So because sodium is sitting in group 1, he has 1 valence electron. And take a look. I'm just going to bring up my pen here. Wait for it to load. Sodium has a charge of +1. Okay, so it actually tells you on this version of the periodic table, but we know that anyways because of the fact that he has 1 valence electron. When we come over to bromine, bromine is over here, and he has a charge of -1 because he's a nonmetal. Nonmetals tend to gain electrons. So we need to be aware of the valence electrons for both of these. And again, sodium is sitting in group 1, so he has 1 valence electron. Bromine is sitting in group 17. He does not have 17 valence electrons, but he has 7. Okay, so we're going to bring that together and we're going to show the bonding that occurs. So we draw our Lewis structures for each element. And remember that sodium has 1 valence electron and bromine has 7. So we put our electrons around as singles, and then we have 1 unpaired. The metal tends to lose an electron. Again, it's easier for sodium to lose 1 electron than to gain 7 to have a full outer energy level. Same thing for bromine. Bromine, it's going to be easier for him to gain 1 electron than lose 7. So we show that these electrons get transferred over, and now we create ions. So we clean this up, we show a little arrow, and remember how we show ions. We have square brackets. Sodium lost a negative particle. That means overall he has a charge of +1. Bromine now has all 8 electrons in that outer energy level, and he gained an extra electron, so his charge is -1. When I set this up, I need 1 sodium and 1 bromine to form a bond. So this is my chemical formula, NaBr. And when I name this, I call this sodium, so the full name of the metal, and then I call this bromide. And notice that we change the suffix of the nonmetal to IDE. Let's do this again for the next 2 sets of elements. So we have magnesium and sulfur. So we're just going to head over to the periodic table. So again, you have to have a periodic table handy. It's like really, really important. So here's magnesium, and he's got a charge of +2. It tells us that he's going to lose 2 electrons. He's sitting in group 2. And then it was sulfur was my other element. So there's sulfur sitting in group 16, which means he will have 6 valence electrons. So we set this up. We always draw the Lewis structures. So there's magnesium with his 2 valence electrons. Remember, he was in group 2. Sulfur is in group 16. He does not have 16 valence electrons, but he has 6. So we draw them in as singles first and then come around and pair. And you should see how nicely this will work out. Magnesium has 2 electrons it wants to get rid of, and sulfur wants to gain 2 electrons. It is perfect. So we show the transfer of electrons, and then we clean up this diagram and we show the ions that get formed. So magnesium now has lost 2 electrons, so 2 negative things. So overall, he has 2 more protons than he has of electrons. So that's why his charge is +2. And sulfur now has a full outer energy level, and he gained 2 electrons. So his charge is -2. I have 1 magnesium and 1 sulfur. So my chemical formula is MgS, and I call this magnesium. So it's always the full name of the metal. And then remember, we changed the suffix on the nonmetal. So it was sulfur. We change it to sulfide. Last example that we'll do is calcium and chlorine. So we head over to the periodic table. Here's calcium right here. He's sitting in group 2. He has 2 valence electrons. And then here's chlorine. You can see my circles. He's sitting in group 17, which means he has 7 valence electrons. So we set this up. Calcium has 2 valence electrons. Chlorine has 7. 1, 2, 3, 4, 5, 6, and 7. So calcium has 2 electrons to get rid of, but chlorine only needs 1. So what we do is we can only bring 1 of those electrons over to chlorine. And now chlorine's all bonded and full outer energy level, and he's good. But calcium still has this 1 electron left over. We can't forget about that. So what we can do is we can just bring another chlorine around. Okay, when you take samples of these elements and you put them together to bond, you have millions and millions and millions of atoms present that it will be very easy for calcium to find another chlorine and bond itself to it. So we clean it up as usual. Calcium now has no valence electrons around itself. He's lost 2 electrons, so his charge is +2. But I have 2 chlorines now that each gained 1 electron. So one chlorine has a charge of -1, and the other has a charge of -1 as well. And if I was going to put this into a chemical formula, I would write CaCl2. And notice the 2 is a lowercase 2 there, a subscript, because I have 2 chlorines. And when I go to name this, I still name it as I did all the ones above. So it's calcium, right? Full name of the metal. And then chloride, where we change the suffix of the nonmetal to IDE. I know there's a 2 there after chlorine. It doesn't matter in the name. Okay, for ionic compounds, that does not matter. So this is just a little overview, little tutorial on bonding and just the basics of where we come up with the chemical formulas and the names. We'll look into the naming, the nomenclature in a little bit more detail in a separate video.